for joining us today. I am Suchitra Bose, Director for Manufacturing and Industrial Solutions at Google Cloud.
Hi, I'm Simon Floyd, and I'm Industry Director for Manufacturing and Transportation at Google Cloud.
Welcome to the Smart Factory Transformers. In this new video series from Google Cloud, we tell the exciting stories of how manufacturers are in the midst of a transformation journey, digitizing production processes and customer experience using data and AI. In this episode, we will talk about the art of factory data analytics and visualization. So, we have the packed agenda prepared for you today, from the business case to the technology walkthrough. Simon, digitally enabled factories generate enormous amount of data, and many manufacturers are aware of advances in data analytics, AI, and ML technologies. So, how can Google help manufacturers in this area?
Great question, Suchitra. We have our data cloud that provides data and AI tools to all manufacturers that they can use and take advantage of. One example is that we provide time series data insights, in particular anomaly detection for live or for streaming data. And we have a range of machine learning capabilities that can utilize essentially any data set that a manufacturer has. This is really very helpful for manufacturers that wish to perform, say, demand forecasting all the way through to something very traditional like predictive maintenance. It's also really worth highlighting that we've invested in creating a solution accelerator specifically for managing manufacturing data at scale and facilitating use cases that manufacturers very commonly have, so manufacturing KPIs and so on. And many of these can take advantage, of course, of advanced analytics, machine learning, and AI. That solution is called Manufacturing Data Engine. So, Suchitra, before we dive into our products and our solutions, a question for you. How should manufacturers identify where to start their journey?
Very relevant question, Simon. So, as we are working with many customers, so I see that scaling up digital transformation is a little bit difficult. But there are companies who have identified their vision, their goal, as well as they have identified the use cases across the factories. Now, for those companies, as they have identified the use cases and the business value associated with them, they are actually able to reap the benefits by increasing production capacity, reducing material losses. They are even improving their customer service and delivery lead times and reducing their environmental impact. So I feel a visual representation of analytics use cases scaled across factories can truly help companies transform as well as they can increase their competitive positions. So Simon, I know you have spent a lot of time working with Ford and their use cases, especially related to manufacturing data engine. So can you talk about the value we deliver to Ford?
Yeah, I'd be happy to do that. And they say that time flies when you're having fun. And so it seems like it was such a short period of time. And yet you're absolutely true. We've actually, as a company, and as Ford also invested a lot of time in this project. And I'm very happy to say that, overall, we got some really great results for Ford and actually learned a lot ourselves in the process, which I think is really very critical. So one thing I want to point out with this, that the success really goes to the credit of my colleagues and also to Ford for having the right level of executive sponsorship to bring this through. And even though we spent a lot of time together working on this, it was really time well worth all of us spending, because there was a couple of components to this. There was one component to it, which was just sort of the understanding of what we're going to be doing for the organization and having everybody, buy into the vision and the strategy effectively. It wasn't just all about technical deployment. There there was much more to this project. Much along the lines of what you just mentioned as kind of best practices for how people should really get started. And we did something very, very similar with Ford. And so when we got to the technical deployment, the part that's really great is that sort of everybody was ready to go and all the expectations were set on what we'd be able to accomplish as we go forward. And really that mission, if you like, that sort of overall vision was to provide new insights from the data that they already have, whether it be historical information or whether it be data that we'd be collecting sort of live from their equipment on the factory floor. The reason why we sort of built this vision in the first place is that really, as an automotive manufacturer, they're obsessed with product quality, and so that's one area that we thought we could contribute. And then, of course, just overall, efficiency of their production and all the way down to kind of more asset management at the equipment level and looking at health. We did find some interesting data points, if you like, or sort of insights, more than data points, but insights from the actual data itself. We really discovered that getting down to the sensor level, that there were improvements that could be made to the equipment very easily. And before it was just simply unknown. Even though the data was there, it wasn't able to be analysed in a way that people could action what they were seeing, and so we solved that kind of core problem for them. The other part of this is that it then gave us the right platform that we could begin to predict what would happen in the future with the machine. And something that I think is important to note with any type of prediction is that really this is a way of sort of prioritizing your work. So if you know that the machine is going to behave in a certain way going forward, then you can prioritize resources if it needs to be maintenance, or you can prioritize ramping up your production because you've got certainty or at least some confidence in how a machine is going to perform going forward. And then, we expand that not just to kind of machine level, but in fact to kind of line level. And now we're really starting to think much more at the production efficiency level, and then what does that mean for prioritizing production of certain parts or assembly of the vehicle. So something else I think that is perhaps worth kind of noting here is that we did achieve a lot in a short period of time when we had our first go live. In fact, we were able to process 25 million records per week across 100 different machines, and that was for 2 factories that were geographically apart from one another. And what this did is, one, demonstrated that our solution manufacturing data engine does really help with scale in 2 ways. One is that it can be implemented very quickly, and it can give results very quickly, which is important because what it does is it puts together all of the Google Cloud products that you need to make this work, and then unifies the data across all the different machines. So now you have one way of analyzing the information across all across all the lines and then across the factories themselves. Something else that I think is worth noting there is that maybe not for the first time, that might be a little bit of a difficult thing to say, but definitely people noticed that the information was now a lot more usable and valuable than what they were used to working with. And so in the past, they would have said, oh, the information, the first time was when we noticed, it was X, but then, things happened over a Y time frame that got us to kind of, where we are today, which is a little bit more complicated because of the volume of data and the proliferation of equipment and so on. So now we're having this second epiphany, if you like, that's catering to our current, much more complicated environment, and giving us the accessibility to the information in new ways that was not possible before. Now, finally, I think a couple of key points. Just it's a great project, a lot to talk about. So a couple of key points. One that I spoke to is just the ease of use, and so making it sort of one system, one data model, really help people in their own interpretation of the information for their job. And that's really very important. They're going to take actions. They need to back that up with an analysis of the data so that they know what to do. The second part, actually very simple, is that when you have a more traditional on-premise system, expanding storage can be somewhat difficult because you have to raise a purchase order to get the equipment, you have to find time to install the equipment, you have to hope that you bought enough storage and so on. With our cloud, you don't have to worry so much about that. You can just expand the amount of storage, effectively in just a couple of clicks, and then you get to where you need to be. And so that was incredibly beneficial as well because it gave Ford the flexibility to say, I wish to store more or less information at any one point in time. The workforce empowerment piece, I think, is worth sort of renoting is that people really love this. We got really great feedback, and they said, this is kind of like an amazing environment for us because there's all these things that we can learn that will help us in our job that we're performing now and feel great about it. It wasn't just the performance went up, but actually sort of the overall mood went up amongst people. They just felt very positive about what we were doing. And then, finally, just from an IT point of view, making this now self-service for people has just been incredible productivity, increase for the organization in two ways. As IT is not burdened with trying to teach people a bunch of different tools that they have to work with, and then trying to wrangle information, stopping people from trying to dump the data and go to a secondary system and so on. All of that, obviously now much more simplified. And from the also from an OT point of view, from the operational tech point of view, the people that actually are in control and command of those machines now have access to the data as well that they can use as they need it when they need it. So that's it. Suchitra is a great project, and one that we're continuing to work on with Ford, and so I'm very much looking forward to that as well.
So thank you, Simon, for sharing your insights. As you know that as we are working with other customers, I think customers are basically getting similar kind of benefits. I definitely feel that the whole area about workforce empowerment, or whether it is about the ease of use, self-service solutions, these are very, very important aspects to our customers. So I'm really glad that you have shared these benefits and summarized them well. So now we will look at the demo scenario based on manufacturing data engine and Looker from Google Cloud.
Hello everyone, I'm Marcus and I'll be your guide today. Together, we'll walk through some common scenarios of using the manufacturing data engine and Looker from Google Cloud. Using its market-leading AI and data products, Google Cloud created an end-to-end solution for processing, contextualizing, and storing factory data. The solution leverages key Google Cloud products, including Cloud Data Flow, Looker, BigQuery, and PubSub. For today's demo, we've set up a simulated factory that generates synthetic data and exposes it over OPC UA interfaces. We've also deployed an instance of Google's manufacturing data engine and connected it to the simulated factory. MDE ingests, harmonizes, structures, and contextualizes the data from the factory. We have also set up an instance of Looker to visualize the data and enable data exploration. Using this foundational setup, I will demo two visualization scenarios. One, real-time factory visibility with the UI UX optimized dashboards that allow the simulated factory data to be visualized, as well as key KPIs and insights to the relevant user personas. And second, integrated analytics that showcases how easy it is to detect events in Looker. The demo scenario is based on a hypothetical company named Motion PCB Limited. This company is a leading manufacturer of rugged, high-reliability printed circuit boards. You can see one of them at the top left. Motion PCB's customers are mostly automotive suppliers who integrate therefore, quality, longevity, and overall ruggedness of the PCBs are key selling points for a company. Motion PCB decided to embark on a connected factory journey to improve its efficiency, increase quality, and consistency. The company has three goals in the first phase. One, it wants to ingest live factory data. Two, surface this data in views and dashboards optimized for various user personas. And three, analyze events and trends in that data. Motion PCB starts the smart factory implementation with one of their main assembly lines. This assembly line has three machines. One, the stencil printer, starts with an empty circuit board. It deposits solder paste with high precision to prepare electric joints for when the electric components are added later. 2, the placement machine then adds those components, such as ICs, commonly referred to as chips. The machine places these directly onto the solder points where the stencil printer already deposited the solder paste before. At this stage, the solder paste is still liquid and the components are not yet fixed. In the last step, the reflow oven exposes the circuit board to a controlled profile of heat, which solidifies the solder paste and creates a permanent electric joint. At the end of the assembly line, Motion PCB has installed a visual inspection quality control station. This station leverages Google's Coral TPU modules to accelerate ML inferencing. This station was installed only a few months ago. In this demo, we have two personas with different objectives. Carlos is Motion PCB's factory manager. He is looking for a clear understanding of the factory's status and seeing key information at a glance. Carlos started the Connected Factory initiative and led the installation of the visual inspection station. After discovering that quality fluctuates, he now doubled down on connecting the rest of the factory to see where those quality fluctuations are coming from. Fatima is the maintenance engineer responsible for keeping the assembly line running. She needs a more detailed view of each machine and wants to find the root cause of problems to identify the right fix. To help Carlos and Fatima do their job, Motion PCB implemented a dashboard for each of them to show just the right information.
Let's start with Carlos, the factory manager. What you see here is the factory manager dashboard that gives Carlos a high-level overview of his assembly line. In the upper part, you'll see key manufacturing KPIs such as overall equipment effectiveness, availability, yield, quality, and performance. The top right corner surfaces alerts to make sure that Carlos's attention is pointed to developing events early on. In the lower part of the dashboard, you'll see a visual representation of the factory line, along with machine-level KPIs. At the very bottom, we surface quality and performance as time series data. This helps Carlos examine trends very easily. Currently, the factory is operating normally, producing PCBs at its expected rate with average quality. Besides the factory manager Carlos, there's Fatima, the maintenance engineer. Fatima needs to have a more detailed view of the factory to understand not only if there are problems, but also where exactly they are coming from and what root causes are driving them. To this end, Fatima set up her own dashboards without needing to write code. As our solution leverages Looker, Fatima was able to configure the dashboard simply using drag and drop. Fatima set up 4 dashboards for herself. The one here, which gives her an overview of the assembly line, and 3 detailed machine-level views. For example, this tile over here shows detailed quality scores assigned to each PCB produced. This data is coming directly from the visual inspection module set up at the end of the assembly line, and the system can detect the work quality of each of the 3 process steps. Next, let's navigate to the machine views and start with the stencil printer. Fatima set up this page to give her key information about the stencil printer. At the top, she has the stencil printer's key KPIs. In the middle section, Fatima picked a time series view for the printer's 3 sensors: temperature, humidity, and paste flow rate. In our example, these are the 3 most relevant process parameters that determine the quality of this process step. Finally, in the equipment log, you'll see key log entries coming from the stencil printer. The machine's messages are arriving in an industry standard format with a number of different types of messages. Info messages include, for example, order execution, for which the machine simply reports starting and finishing work on a PCB unit. In the log here, you see these arriving in real time. Now, let's see what happens if the stencil printer experiences a failure. To do this, I will open the simulator UI, switch on the first event, and collapse it back. Let's also set the view to show the last 10 minutes only, to zoom in on the most recent developments. Once done, the dashboard refreshes and then shows the data. Okay, now we notice a couple of things. First, the flow rate is deteriorating. That's interesting. Let's see if the machine reports any relevant status messages by looking into the event log below. Here, we notice that the low-level process control system in the machine detected that the flow rate is abnormally low. Good to know. Notice that Fatima doesn't have a time series dashboard set up for quality versus flow rate. However, she'd like to understand if the lower flow rate is a cause for concern in terms of quality. This is where Looker comes in. It allows Fatima to ask follow-up questions and answer them herself very easily without having to involve a data analyst, a programmer, or anyone else for that matter. To explore the relationship between quality and flow rate, Fatima simply clicks Explore from here from the flow rate tile. This brings up Looker's integrated Explore view that allows her to investigate any data. What you see here is a chart with the average flow rate over time and a table with the data below. Let's add quality to it. In the sidebar, I simply search for quality and click to add it to the chart. Last, I click Run to ask Looker to pull the data from BigQuery. As a result, I see both flow rate and quality in the same chart. And really, there seems to be a strong correlation. Quality has been stable, but deteriorated quickly after the flow rate went down. This puts Fatima on the right track in her maintenance investigation. Fatima investigates the stencil printer logs and determines that the stencil printing head needs a replacement. She replaces the printing head and will reflect that by switching off the simulated event. Returning to the office, Fatima checks to verify that the quality scores are returning to normal. However, as in any factory, there is always something going on in Motion PCB's assembly line. Let's see what happens when we switch on the second event. Okay, so now we see an alert in the dashboard. Something is wrong with the placement machine, so let's dig in. I'll first open the placement machine dashboard. Here, we have an overview of key sensor time series for the placement machine. One sensor measures the acceleration of the placement mechanics as it moves across the circuit boards to place the chips. The other sensor, on the right, measures background vibration, as the machine is highly sensitive to any excess background vibration. We see that the background vibration has been pretty high for the last few minutes. Acceleration also looks a bit unusual, exceeding normal levels. The log also shows several event messages produced by the machine, which state that it has trouble stabilizing the placement mechanics. Fatima heads out to the factory floor. Arriving at the placement machine, she opens the maintenance view for this alert, but this particular error hasn't been detected before and the root cause is unclear. After some digging, she notices that the power unit of the machine is excessively loud and creates a strong background hum. Luckily, she knows how to repair the power unit and does it on the spot. To reflect that, let's switch off the simulated event. After a few moments, we observe the vibration values returning to normal. Fatima has done a great job repairing the equipment. Now, back to Carlos in the office. Carlos is wondering if he can do something about the OEE numbers, which have some room for improvement. Looking at the quality scores for each machine, it becomes pretty clear that the quality produced by the reflow oven is quite low. This looks like a promising opportunity to dig deeper. Carlos asks Fatima to investigate. Let's look at the reflow oven dashboard to see if we can find anything that could explain the problem. The machine reports no errors, the log looks clean. So nothing obvious here. Let's look at the sensor values if we can see something. In PCB manufacturing, the reflow oven needs to expose each circuit board to a specific temperature curve to harden the solder paste. The only thing that stands out here is that the peak temperatures seem to vary slightly in their heights. Mousing over the chart, it's clear. Some peaks are at 230 degrees Celsius, some at 250 degrees Celsius. But does this affect quality? And if yes, which of the temperatures produce better quality? Let's go into Explore mode to investigate. First, I will customize the chart to focus on the most relevant information. To this end, I'll remove the humidity data series from the chart, and I will also set the time filter to the last 20 minutes. Next, I will add the average quality data series to the report and click on Run to fetch the data. Looking at this, it's pretty obvious. Higher peak temperatures result in better quality. Seems like the reflow oven is not able to consistently create the right temperature pattern. Fatima decides to involve the machine OEM in this. Looker makes it easy to share this view right from the screen. By clicking on the menu button, then on Send, I can share the report in various data formats and over various channels. For example, email. Let's send this to the supplier and add a note. This helps shorten time to repair, sometimes dramatically, by using data to detect root causes quickly and remotely. In our scenario, the supplier knows of a bug in the oven control unit firmware that can cause temperature patterns to fluctuate. The oven OEM rolls out an update over the air to address the issue. To reflect that, let's modify our simulator. To see if quality improved, Fatima filters for the last 10 minutes and refreshes the data. And the quality improvement is clearly visible. This will also drive up OEE and achieve Carlos's objectives.
Well, that's it for today's demo. I hope it gave you a good overview of the virtually limitless possibilities that we can help unlock for our customers.
Thank you, Marcus. What a great session. Now let's talk about scaling this technology across factories and enterprises. Hi, I'm Somil Singh. I lead the global manufacturing practice at Quantify. Let me take you through the typical journey for such programs from the pilot phase to a large multi-line and multi-plant scaling. The program normally encompasses three steps, namely discovery, pilot, and rapid scale-up. In the discovery phase, which is spread across 2 to 4 weeks, interactions are held with a cross-functional team from the client. They include representatives from senior business leadership, plant operations, and IT. The purpose of these interactions is to handhold the client to zero down on the key challenges and identify a corresponding solutions roadmap. A joint implementation plan for this program, along with the key client resources, time requirements, IT prerequisites like network security and data availability, and dependencies, are called out to ensure a successful and seamless pilot in the next phase. Key metrics for success and the calculation methodology is also stipulated here. Based on the above, the ideal line for pilot implementation is identified and the downstream use cases associated with the data being gathered are defined. They could be predictive maintenance, inline product quality, throughput or yield maximization, root cause of failure analysis, OEE optimization, and so on. In the pilot phase, which can be anywhere from 8 to 12 weeks, the first step is to implement the connectivity between plant equipment and the cloud. The IT team plays the pivotal role of ensuring the right hardware, network connectivity, and security foundations are set up. Next, with the plant instrumentation and controls team, the equipment tags are mapped and then configured in the cloud to enrich and contextualize the data to industry standards. Post this, the data begins to flow into the cloud. It is now available in the unified data warehouse, ready to be validated for downstream AI and ML use cases and for visualization purposes. The pertinent AI ML models are then developed and deployed. The results and learnings from this are assessed and shared with the client leadership for further scale-up planning. The subsequent scale-up plan, which can be anywhere from 2 to 4 months, is classified into two phases: horizontal deployment across other lines within the same plant, and second, the rapid deployment across other plant locations within the client organization. The first step ensures that the program team understands the nuances associated with scaling up and identifies any possible hurdles or challenges. An iterative wave-by-wave deployment model is used to optimize approach and evolve the plan for rapid deployment across other plants within the organization. During the second step, the solution are deployed across multiple plant locations simultaneously, leading to significant time and commercial efficiencies. Some of the key benefits of using this approach for scaling include a unified data warehouse with seamless data ingestion, contextualization, processing, and democratization. User role-based visualizations give visibility and insights across operations. As a package solution for end-to-end data pipeline, MDE reduces time to develop and deploy AI/ML-driven use cases like predictive maintenance, visual inspection, and many more. Organization-wide rapid deployment bringing down implementation timelines from years to just a few months. Enhanced data governance and security policies as out-of-the-box features of the solution. All of this at optimized costs, and hence the client derives maximum value. Back to you, Simon and Suchitra.
Thank you, Samil, for the great insights and for being a great partner. Just to recap today, we walked you through a couple of use cases and scenarios, in particular, role-based visualization tools and scenarios, ease of use of tools and services, democratization of tools through low or no-code environments, and self-service solutions. In other words, minimum need to engage IT for deployment of solutions. So, Suchitra, this wraps up, I believe, our session today. Before we go, what are the top 5 reasons a manufacturer works with Google Cloud?
Great question, Simon. So here is how I would summarize. So first, accelerated data transformation. We provide industry-leading machine connectivity through more than 250 ready-to-use machine-level protocols. Now, secondly, quick-to-end setup through automated deployment of a ready-to-use setup on Google Cloud and an auto-configured edge stack. Accessible data analytics, insights, and easy-to-use AI, which is putting the best of Google's data analytics, artificial intelligence to work into industrial environment. That is another reason why manufacturers would choose Google Cloud and Manufacturing Data Engine. And fourthly, I would say advancing the shop floor workforce transformation. There is a labor shortage, and I think it is very, very important that as manufacturers automate some of their processes, it's going to be easier for them to basically, decrease that labor and the skills gap. And last but not least, we provide an integrated digital twin engine for asset hierarchy and models, and integration with our supply chain twin, and optional integration to third-party digital twin providers. So I hope you found the information we shared today to be helpful. Reach out and we will welcome you on this journey. Thank you for watching this episode.